Hi everyone, I am back to share on a new webinar with you, specifically focusing on robotics and coding. Today we're going to be focusing on game-changing robotics products. So I have a few webinars in this series already, one where I focus on coding activities that you can do without a device, and then the following one was talking about coding programs that you can do with a device. Now I wanted to kind of dive in a little bit further, take it to that next level, and start sharing some robotics products that you can use in education to support your students in learning how to code. So if you haven't watched the previous webinars, I suggest you press pause, go back, watch those ones, and then come back and watch this one. So my name is Naomi Hartl, and I am a former educator. I taught in Saskatchewan, Canada. I taught multiple different subject areas over the years. I've taught math, science, physical education, health education, career guidance. I've taught home economics. And I focus on grades 3 through 12 in my teaching. I'm now living in the United States, and I'm the STEM and science subject matter expert for school specialty. There's my contact information right there if you have any questions for me. So what are some learning objectives, some questions that I am hoping that we can answer by the end of this webinar? So the first one that I kind of want to focus on is, what are robotics? How do they fit into education? What does that look like? Next one are just talking about the benefits of teaching it, and then figuring out which robotics products are the ones that we really want to implement into our programs. And I'm not going to focus on the main ones that you're going to see all the time. I'm going to give you a couple ones that maybe you don't see highlighted as much. If y'all want some where we're focusing on some of those main ones, let me know and I can definitely do that for you. So first of all, what is a robot? So I want you to just pause the screen here. And I want you to write down, just think of what is a robot in your own words. Don't Google it, just think about it. Okay, so one of the definitions that I found online about what a robot is, it's very simplistic. A robot is a mechanical device that can be programmed to follow a set of instructions. Now I've talked to different vendors that we have who sell a lot of robotics products, and some will say, a robot is something that can sense, think, and act. Very simple. So these are some robots that you might think of when you are picturing robots that come to your mind. You might think of Bumblebee from Transformers. You might think of R2-D2 from Star Wars. You might think of Wall-E, right? There's so many different robots that we think of that come to mind when we talk about robotics, just in the world in general. But what does that look like within the education sector? Well, here are a bunch of different robots on the screen, and they all look and do things a little bit differently. So in the education sector, you're going to find all different kinds of robots. Each robot serves a specific purpose. Some you might build, design, and then code, like this one right here, like this one right here, and this one. And then others might already be built and you just code them, right? You write programs for them. So I have just a few up on the screen. Obviously, there's a ton more. And some of these you might actually recognize and maybe you don't. You've got Botley, you'll see some Kubelets, you're going to see a robotics arm from Hamilton Buell, you're going to see Rover from Sphero. So the entire system of robotics in education has been designed to be easy and safe for students to operate and learn. It is so simple that kids with no programming skills can operate them and make the best of it in no time. What was earlier restricted to companies and laboratories is now available for people of a young age. So what are the benefits of robotics programs in education? So let's take a look at some of these benefits. I have 5 popped up on the screen. Obviously, there's way more benefits to teaching robotics in school, but I just wanted to narrow it down and keep it concise. So let's look at the first one, the blue one on the far left side, engaging ways to teach essential STEM and STEAM skills. And this is one of my favorite ones because when students can design their own robot, it can boost their self-confidence and self-esteem. They learn the skills needed to create precise and accurate instructions and have fun while learning valuable lessons. The next one is that 21st century workforce. So when we teach robotics in schools, it gives us the opportunity to address the growing demand of teaching STEM subjects while learning how science, engineering, math, and technology work together and interact. Robotics is the future of study and work, and work, and it's so crucial to have kids learn about the basics of robotics, because they're going to be focusing on this later in life, especially when it comes to that coding aspect. This is going to be, I predict in the future, this is going to be a requirement of many different jobs that are out there. So if we can get a student started within schools, I think this is going to be extremely important. And if we can do it with robotics, it just allows them to see where they're going and where they're at, which I'll get to in a little bit. So the next one is that community involvement. As another benefit, robotics is a widespread educational technology that could lead to more community and educational opportunities, from robotics competitions to showcase for family and friends, from where robotics drive community involvement, giving students something of which they can be proud of. I mean, I grew up participating in choir. I grew up participating in we called it a variety show, which was basically theater. I grew up playing sports. Like, those were my ways to be a part of the community, to have that community involvement. And for some students that maybe that's not their thing, here's another way that students can really be involved with their community, and engaging in ways that support them and engage them in those essential STEM and STEAM skills, and they have fun, right? Fun is that key word. And then we go to the cross-curricular aspect. So through the process of designing, building, programming, deconstructing, and operating robots, students gain hands-on, deep practical knowledge of science, technology, engineering, and math, and maybe even art if you focus on STEAM. And they get an understanding of how these subjects link together. Robotics helps address the growing demand for teaching science, technology, engineering, art, and math in school. And then finally, awareness about technologies and concepts. So when students program physical robots, it's easier for them to see what goes wrong as they learn what robots can and cannot do. Since STEM is a composition of, as I've said it 3 times already, science, technology, engineering, mathematics, or maybe art if it's STEAM, it also touches mechanical engineering, electrical engineering, electronic engineering, and computer science. It deals with concepts like design, construction, operation, and application of robots, and also involves the use of computer systems. So that awareness about technologies and concepts is key right here, and definitely one of those benefits. So what are some new products that can support a strong robotics program? We've talked about what is a robot quickly. We've talked about some benefits of it. Now let's dive quickly into just a couple robots that you could potentially see using in your programs. Now, you've all heard of the Wonder Workshops, the Ozobots, the Spheros of the world. So I'm not going to focus on these ones because most of you have heard about these. And if you haven't, I definitely recommend you going and checking them out. Or I can do a separate webinar on this if you'd like me to. Just shoot me an email. So I'm here to share a couple different products that maybe don't come to the forefront of people's minds, but are still key products that I think your students would benefit from learning. And here's why. So I've broken it down into 3 different categories, and I'm going to talk about one product for each of these categories. So I'm going to pick a robot that you can code specifically. Now, just like Ozobot, Wonder Workshop, and Sphero, these are products, robots that have already been built that you can code. So I'm going to give you another product like that's not talked about a lot, but is still a really, really neat program and robot. The next one I'm going to do is a robot that you build and then you program and code. And then the final one, we're going to kind of break it down a little bit further. And these are ones that you can build, but this really focuses in on electronics and circuitry. All right, so the first one I'm going to look at here is on coding a robot is Root RT1 Coding Robot. Okay, so this robot has been adopted by schools and robotic clubs and includes premium features designed for classrooms, including color sensors and the ability to navigate magic whiteboards. And yes, as you can see on this screen, this robot is connected to a board. All right, this is a whiteboard and it's magnetic, and it's a magnetic whiteboard, and the robot is magnetic. And let me tell you, because I have one of these robots at home here, I don't have a magnetic whiteboard, but I have a filing cabinet. And it sticks so well onto that filing cabinet. Even if I bumped it, or if somebody brushed up against it, or even leaned up against it, that robot isn't going anywhere. The pull of that magnet is so strong. I absolutely love it. So it's very, very cool. So children can code their Root robot to draw artwork, play music, respond to touch, light, and sound, and even more, all while exploring the fundamentals of robotics. Heck, Since you even have it on a whiteboard, you can even have them answer math questions, code them to answer math questions, which would be pretty fun. So just a couple things. Let's go through this one. So you can get anyone coding with this product. So as you can see, top right corner, it says ages 6+ without any helping hands. So if you want them to be able to use this just on their own, this is a great product for your early elementary kiddos. So Root Robot actually comes from iRobot. Now you might be thinking, where have I heard of iRobot before? So you all know those the vacuum robots, the Roombas. So this is iRobot's take on an educational robot. So you can definitely see the similarities in Root compared to the Roomba. So Root brings life to iRobot's passion for robotics to empower people. So Root is great for all ages or expertise. Students will have interactive experiences while using Root. This robot can be used solo or in a group setting. There are over 30 sensors and capabilities that you can do or that are used with Root. And one of the key things here, I had a conversation with the vendor when I was preparing for this webinar, and they talked about accessibility. And I was like, "Ooh, let's dive into that a little bit further." So one of the things they said that is if you have students that need extra support with motor development, or maybe have limited motor development, those touchpads on the top here of Root, right there, you can also see them right here a little bit better. So when you tap those, it's a bigger surface area. So, and they're pretty sensitive. So you can use any body part to touch them, which is pretty amazing. The other part is when, and we'll talk about what the app and the simulator looks like and the coding aspect of it. But when you're doing that coding piece, they have it set up that when you're dragging and dropping things into different positions, if you're getting within the area of where you want to drop, it'll automatically kind of latch and connect into it within the program, which is also key. You don't have to put it all the way when you're dragging an icon or when you're dragging something over. You don't have to put it exactly in the position of where it needs to be. You can bring it close and it will kind of snap into place, which is another piece too. So you don't have to have those complete fine motor skills to be able to use this product, which I thought was a really cool thing to highlight. So when you get the product, what is included? So you get your charging cable, you get the vinyl clings, there's an eraser cloth. They also give you this whiteboard grid. Now this whiteboard grid isn't magnetic, but not everybody has a whiteboard. So maybe if you're at home or even at school, you might not have access to a whiteboard, or not every child will have access to a whiteboard, or you might not have a lot of whiteboard space. So the nice thing is they have this whiteboard that just folds up here and then unfolds into this really big grid, which is really cool. They give you some dry erase markers that go with it that just plug right into your Root, and then you get the one Root coding robot. So basically it's designed for educators and it's everything that you need to get started right out of the box. So you open it up and it's ready to go. So let's talk about the 3 different coding levels, which is a key point for me as to why I wanted to share this robot with you all, other than it being that magnetic piece too, the accessibility to it, but the coding aspect. So it translates code across 3 coding levels. So Root was designed as an education product from the ground up, which fits perfectly with using robots as a way to turbocharge STEM-focused learning, or make it that game-changing, like I called it at the beginning. The Root coding app translates code across 3 levels, growing alongside users as their skills advance. And you can go back and forth between these levels. So it's not like you just finish level 1 and move on to level 2 and you can't go back to level 1. So you can kind of interchange between the two. Level 1 is purely icon-based language, ideal for beginners and non-readers because they can code robots' inputs and behaviors just by using the pictures and the colors, which are definitely key. No reading required. Level 2 infuses text into graphical blocks, so providing greater precision with values, logic, variables, and flow control statements. So as you can see right here, again, color-coded as well. And then level 3 reaches a complex text-based interface that is designed to teach the structure and syntax of Swift, which is an Apple program, which is, the coding language of iOS device. Now, it is compatible with iOS, Chrome OS, Android, and web accessible browsers too. So just so that you know that as well, this program is great for any device that you have with your students, so you're not limited. Another key thing here, and this is one of the parts that got me super excited about this robot, is that the Root app, which again is web-based or device-based, has a simulator called SimBot that you can use without a robot. You can just download the free version of the app or use it on the web to access the simulator. And this simulator is also a great tool for practicing code. So if you are doing distance learning right now with your students and they cannot access a robot, or you don't have enough robots to go home, then this is a great option for you and your students. You can get your students set up with this free simulator, and then once you're back face to face, they can then start coding the robot. So this allows them to start working on understanding the coding and the programming language ahead of time. So it's not like you're just giving them a different app to use, and then when you get back face to face, then you're going to teach them how to use this. So you're gaining time almost right now with having them work with this program right now, and then being able to have them use it at school. Or you can have them using the simulator, sending the code to you, and then you can program the robot while you're doing that distance learning piece. Again, it's supported on for all devices, from Apple to Android to Chrome. And then finally, we've got some resources here that you can check out. So you can start coding at code.irobot.com, and then you can also check out some different Root activities that they have on their education learning library. I highly recommend you check this out. I could have talked about this robot a whole bunch more, but obviously I want to jump into some of the next products. So definitely check out Root from iRobot. So the next one we're going to focus on is building and coding. So you might think of Lego, you might think of Vex Robotics. I wanted to give you something a little bit different to think about, and this is the UB Tech Education U-Kits. So as you can see, the little kit there, the robot, and the student there kind of moving things around and manipulating things throughout their app. So with UB Tech, they have a couple different lines of robotics products. I'm going to focus on the U-Kits. They have a U-Kit beginner, intermediate, and they have advanced, but since I'm really focusing on elementary and middle school here, I'm just going to be talking about the beginner and the intermediate kits. So beginner level kit is definitely recommended for students new to coding, and it's appropriate for elementary and middle school. And then the intermediate level kit is to build on students' coding skills already, and it is appropriate for elementary and middle school. Now, they are both appropriate for elementary and middle school. It really just depends on the level of coding and programming that your students already have. And which one you would want to do, because you might have students in third grade that could already use that intermediate kit because they've been coding since pre-K. And you might have kids that are just starting out, and then that's where your U-Kit, that are just starting out in sixth grade, and that's where you're going to use that U-Kit beginner. So I'm going to dive into a couple of these just to give you a little synopsis of what is involved in each of them. So the U-Kit beginner has accompanying NGSS aligned curriculum for grades 3 through 5 specifically. It seamlessly incorporates STEM instruction into classrooms. So it supports up to 4 students per kit, appropriate for ages 8 through 10, grades 3 through 5. Again, you can level this up or level it down. The U-Kit beginner has a total of 300 pieces that include 1 main control box, 1 battery, and 4 servo motors. It has a free app that you can use as well. And I'm going to dive into the app and a little bit of its features, because this is what the app is what excites me the most about this product. And then it also has 13 pre-programmed models in the app, and this is just one little one here that I put up on the screen. But there are models that the app will teach you and walk you through how to build. Now, obviously, your students can build whatever they want with this, but there are some builds that they currently can do that it can support them through it and support them coding it. Then the U-Kit Intermediate, has an accompanying curriculum for grades 6 through 8, and it's designed to deepen students' interest in STEM, computer science, and robotics topics. So this one also supports up to 4 students, whereas the U-Kit Beginner had 300 pieces or more. The U-Kit Intermediate has 500 total pieces. So it includes 1 main control box, 1 battery, and 4 servo motors, just like the U-Kit Beginner. It also has 1 IR sensor, 1 touch sensor, 1 speaker, and 2 LED lights. So it's adding on that next layer. Now, just remember that if you had both of these kits in your classroom, these pieces are interchangeable between everything. So kids could mix and match everything or put the kits together, and that would be no problem whatsoever, because all the pieces, they all connect, they're all the same thing. And then with this one, whereas before the U-Kit Beginner had 13 pre-programmed models, the U-Kit Intermediate has 15 pre-programmed models in the app already. Okay, so let's talk about that app. So the UKIT EDU app, you can just find this on your Google Play Store. You can find this on your Apple Store. Um, the UKIP beginner, so UBTech's education app lets students build and program their robotics products with block-based programming and text-based preview in Python. So you can take a look at your block-based programming in that text. You won't be able to edit the text, but you can see, okay, so if I did this block programming, what does that look like in text? So it allows your students to be able to transfer that knowledge. They get quick access to all pre-designed models referenced in the UKIT lesson plans. It has advanced 3D, 360-degree modeling system. So the cool thing about this, and unfortunately I don't have a photo for you up on the screen, but the cool thing about this is most apps will show you when you have those pre-programmed, those builds, most apps you can like zoom into it, but you can't rotate your model. So I know when I've been doing builds and I'm trying to figure out where a certain piece goes or what that looks like or the size of the piece. I'm trying to like move, I'll zoom in, but I can't turn the robot around to see exactly what that's supposed to look like. Within this app, you can actually rotate 360 degrees in that 3D model to be able to see where all the pieces go. And that was extremely helpful for when I was building those specific models. My favorite part about this app is that it has pose, record, and play tool. Now, this actually came from an idea that a student gave the vendor when they were creating it, and I just think it's genius. So this pose, record, play tool helps novice coders easily program motors and sensors by posing the robot and the motion that they want to do, and then recording the coding that it takes to do that movement. So you can have your little robot in this position, let's say even this one right here, and let's say you want to be able to open and close this mouth part of your, or the claw, open and close the claw. So all you have to do is physically being able to take, grabbing onto the top of the claw and the bottom of the claw and just physically moving it back and forth. And then it allows, once you press the pose, record, and play, once you move the mouth back and forth, it'll actually give you the coding for that to tell you how you can code it to make it work. So it's almost like coding backwards. So this gives your students a way. So your students might be struggling to be like, okay, I can't get it to open and close. I can get it to open, but I can't get it to close back up again. So if they can just do that pose, record, play, it now gives them the opportunity to see what that coding looks like. And it just makes it easier for them to understand how that coding works. Sometimes it's like you get the answer and you got to work backwards, which why not, right? If it's going to help them learn code, perfect. So another really cool feature. So their technology does not require any internet, as you only need a Bluetooth connection, which is also really nice in the world of when everybody's on their devices and our bandwidth can be limited sometimes. So here's just the UKIT ability app oh my goodness, I can't talk today. The UKIT app compatibility chart. So you can just see if the systems that you are currently using, if it operates on those systems. All right, and then our final one that we're going to be focusing on, where it's where you can build your robot and then code your robot. So it's under that kind of umbrella, but we're going to focus in specifically now on electronics and circuitry with SAM Labs. Now, SAM Labs isn't a new program. It is not a new product line, but I don't hear people talking about it all the time. So I really wanted to give you as a viewer here an opportunity to see what SAM Labs is all about. So SAM Labs is a curriculum-aligned courses in STEAM and coding, which empower teachers to prepare a generation of computational thinkers. These courses provide a comprehensive teaching and learning suite. It utilizes a combination of lesson content, software, and hardware to give students a hands-on, minds-on experience. So as you can see here, encourages creativity, promotes collaboration, encourages critical thinking, and is linked to real-world applications. So you have your standards aligned lessons and content, which are very easy to follow and work through. You have the software that's included, well, whether it's flow-based or text-based, and then you also have the wireless hardware that goes with it, the blocks. So we're going to dive into the two different courses that would support elementary and middle school level. So you have your STEAM course, on the screen it says grades 2 through 5 lesson content. They've been working on K through 5 as well, so those will be coming up very, very soon. But their curriculum course for really 2 through 5 and soon to be K through 5 brings STEAM and computational thinking into science. It ignites critical thinking with over 75 K through 5 standards aligned lessons, including all teacher and student resources to foster real world problem solving. They use their SamSpace app right here. And this is, it engages in computational thinking and creativity using SamSpace, their flow-based programming app. It's very intuitive, visual, and it has a flow-based coding, just again, to allow students to see how things are moving and how things are working. Sometimes block-based isn't simplified enough, whereas this flow-based really allows students to see how things are working. And then you have the hardware. So it's supporting group collaboration and communication with SamLab's course kit for up to 30 students. If you look at their course kit specifically, you can have 10 sets and 3 students per group if that's the way you want to kind of split it up. And these kits include 10 light sensors, 10 RGB LEDs, 20 DC motors, and then some different plastic accessories, as you can see up here on the screen. And then we have our Learn to Code course, and this is grades 4 through 8. So this teaches the fundamental of computer science and coding through physical computing. It ignites critical thinking with over 50 standards aligned lessons, including all teacher and student resources and some 3D printing lessons as well, which is pretty cool. So if you have that 3D printer, this is a really great program that you can use to integrate with it. So while the previous one used the SamSpace app, this one actually uses Google Workbench. So it engages in computational thinking and creativity using Google Workbench, which is a block-based programming app. And then the hardware that is used, so this supports group collaboration and communication, just like the previous SamLabs course kit did. Same thing with 30 students, supports up to 30 students. It has 10 microbits and a battery pack and data cables. Now you can get these kits with the microbit or without the microbit. You get access to 10 sliders, 10 light sensors, 10 buzzers, and then multi-charger built-ins as well. So just a really cool programming that you can use that has the lesson content, the app, whether it's Sam app or the SamSpace app or Google Workbench, and then the hardware that goes into it. And the hardware can be interchangeable between the two as well. So there you have it. We've talked about what are robots and how they fit into education. We talked about the benefits of teaching them in school. And then we talked about the 3 different robotics products. We talked about Root for My Robot. It was the RT1. We talked about UBTech UKids. And then we talked about Sam Labs and their 2 different courses that they have with their lesson content, their app programs, and then their hardware. So the software and the hardware. So my name is Naomi Hartl. Thank you so much for joining me today. If you have any questions, my email is right there on the screen. If there's other topics or ideas that you want to hear from, let me know, and we can definitely continue the series, our coding series. So thank you very much. I hope you have a great day.